Good morning. Oh. Oh. Monday. Ooh. Yep. How's it going? Did I write down a problem? Oh, yeah. We're reworking the light casting. Upload tile data needs to be finished as it does not contain all of the data a tile consists of, right? Just pulled an all-nighter? Why though? What? It's quiet? What's quiet? The all-nighter? What do you mean? What's quiet? The all-nighter is quiet. No, I mean, why did you pull an all-nighter? You just felt like it. Just how it worked out. Fair enough. Oh. We're unfortunately doing things I hate. It should be easy-ish to do this here. Tile data. Where's the tile? Or actually, where is the tile data? Tile data. Compute tile data. That looks like this. So, we have the tile type there. The tile data is all of this. And then the rest... Not so sure. Shouldn't need this, though. Yeah. Man. It's like, how much information is this right now? This is too much. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think. Yeah, that's 3 gigs. 3.5 gigs. You can't do that. I don't remember what I was doing with the tile data. Even this is a lot. Because here we are fetching building and room IDs on the tile. Did I always have that there? Compute tile data. Contains compute tile data. Contains this shit. This was added recently. Right, I'm unpacking this tile data into that. I think. See, the issue is that knowing what building a tile belongs to is kind of hard. Because how do I do it? I can give the tile itself like a building, either literally just a building reference, or give it an ID, like a building ID. That way it can just be a byte, and I think that's more or less what I'm doing right now. But here's the problem. Hold on. No. The problem is that if I make the room be like an area just stored in a list, and then in order to find out where the tile, like if is the tile within this or that room, then we have to make a boundary check against that, right? But that's okay. Like I can do that. That's not that big of a deal. However, the issue arises when we are inside of the shader, because then there's a question of how do we find out there? Because it's actually in the shader that we're handling the transparency, because the rooms really they're really about handling transparency. And what that means then is that I can think of a couple of ways to do this, right? So we could just make a list of rooms, and the rooms are... It's back already? Oh, God damn it, it's so annoying. Look. They have this fucking gift a subscription thing here, and it's so annoying. Just takes up the entire thing, so I'm just trying to, like, delete it here. But half the time when you do it, it, like, cramps out. Let's hope that fixes it. And also you have to do it every single time, it's terrible. Alright. It keeps swapping between things, too, so I'd like... Huh? What? Yeah. I just see something in the periphery where it's like, oh, someone typed something? No, it just switched to the next ad. Thank you. Anyway. The way it works now is that each tile just contains the building ID. So it's just like, this tile belongs to building 5. And if it does, then we just check building 5's transparency, and then we set the tile to that transparency. But the tile also needs to contain the ID, because it needs to check against its neighbors. It needs to figure out basically where the base of the building is by reading the tiles in order to set its transparency properly, because the transparency is tapering, it tapers off from the bottom and up, right? So that's why I have room and building IDs inside of the tile. But like we just established, storing that, like this tile data here, this is like okay to store, but I think this is also not something that's worth having in a buffer. Well then here, the compute tile data, here I have recently added the tile state and the detailed data, which isn't good. Tile type, it shouldn't be there, but it it needs to have the building ID, room ID, roof IDs here. But just these 3 on their own is about 1.2 gigabytes. Potentially. It depends on how large the map is. It could be much less. It could be much less. But potentially 1.2 gigabytes. So then... I feel like the the other alternative would be, and I think it would actually be good to do that, is to simply create the buffer structures or the vertices on the GPU. And then we just do an AABB check against that on the GPU as well. And we do that every single time where we need to read a tile. We will also do an AABB check against the rooms, but it also means that you have to do that against all of the rooms. Unless we have area data that says like this area contains these rooms. And then it would be much faster, which I can do that. But it's a lot of work. And it's also an issue of we'd have to reconstruct the room every single time, almost, I think. No, not exactly. We can make a buffer that takes an int3. Because then that would be the vertices. And then you just have like room 1 starts at 0, room 3 starts at 5, you know, just like we're doing with the rest. And then you have like a count thing. But why did I decide to add this in here? I felt like I had some epiphany the other day, and I was like, oh yeah, we can just do that. Well, the reason I put the detail data here is because it should just be there. Because before the detail data was written anyway, it was just written to a texture. So it didn't really change anything. So it should just be here. The tile state. Don't think tile state should be needed to be here. Let's see, it's in here somewhere. Bake compute tile. Current state is baked into tile to bake. So in that case, there's no reason to have that anywhere else. Rooms are baked into each other there. So tile state. Yeah, that doesn't make any sense. We already have this. Tile type. Tile type is just 8 at the moment. Tile type should easily be bakeable into detail data, I think. His tile state is in tile data. And that means that the detailed data has see. That's it. We have it has 8 states and we have 8 bits, which is 255, right? So that's plenty of space because it only needs to be 1 state. But yeah, I'll be right back. We have like building. A building could technically... See, this is why it's not good. And why I would like to get rid of the current implementation. Because... a room... can belong to... Let's say that red is building 1. So it belongs to building 1. Or to room 1. But then we have another room that looks like this. And this room is room number 2. And it looks like this. Right? And this is where it becomes a mess. Because now these belong to 2 rooms. And how do you handle that? Right now, the way I handle it is that each tile has a list, an internal list, which is terrible. Because that's like 64, like instantly just like 64 bits just for like the reference. And then, you know, and then I don't know how many bits the entire like list instance is for 4 integers. I think it might be 4 bits. Yeah, it's a list of, or a list of bytes right now. And then these get baked into 1 integer later. So I can only have up to 4 room numbers. And then that gets, all those 4 get baked into 1 integer in 4 slots, like allocators. And then I extract them, and then we check against each room number, and we see if any of the rooms are transparent, then we set it to be the one that's the most transparent, pretty much. And it's just awful, to be frank. So ideally, we should rework this entire system, which is also like, I hate even saying that. It wouldn't be that difficult to do, though. But it would take time. It could take a lot of time. I have automated systems to create the rooms and the buildings. I actually don't think that those systems would need to change. I think they would just need to have to be redirected to instead of writing those rooms to here. I mean, hold on. Here we have rooms. And the list, it's a list of rooms. And each room is a list of vertices. So we're actually doing it already. We have a list of vertices, and then it has a height. But I don't really like the height system that much either, but it's like okay. It's an okay system. I'm just thinking, like, how would you do it otherwise with vertices? Would you have, like, a top vertices, bottom vertices? Because it's not that easy, right? Like, when you're working in 2D, it's very easy. Then you just have, like, a vertex here, vertex here, vertex here, vertex here. And then you just check if the tile falls within any of this. But once you have 3D, then how do you do it? Because now we might have vertices up here too, right? So how do you create a proper bounding box here? Because it's a polygon, right? So that means it could be like any shape. And that's what is bad, I feel. One way to do it is to simply construct everything out of actual bounding boxes. Like, you use rectangles to create the entire house or entire room. So if it looked like this instead, for whatever reason, then we would create a bounding box here, and then another one here, and then we construct the room out of that, and then it would have to just make a check against this box, and then against this box. And then that way, it'll find, like, whichever box it checks against, it will just find, like, room number 2 here, for example. That's possible and doable. Because a three-dimensional polygonal bounding box. How the fuck do you even do that? I don't know if that's actually doable. I don't think it's worth it. It's not something that's worth pursuing at all. compared to just kind of limiting your buildings to being a little bit more squarish, I suppose. Um, no, because you'd have to do it with some kind of like, because it becomes so much more complicated when you have the 3D involved, because then you have lines going up and shit like that. Can do a 3D point in polyhedron test. But instead of, because the way my system works is that when you have a polygonal room structure like this, and you just do like this or whatever, And then you have the point you're checking is here. You then check I actually think it could be simplified to some degree, maybe. But either way, what you do is you check how many times a line passes by the object's point. And if it passes by once, then that's a success, success, success. And here it doesn't pass by, so that's nothing. This is a success. Right. And if this had been 2, then this would have been failure. Same thing here, if this was 2, this would have been failure. Because it could look like this, right? And then you can see up here, you then have 2. So then when we pass by here again, that's a failure. Here as well, this is 2, so that's a failure. It doesn't have this here. And apparently you can do this in 3D too. But instead of counting lines, you count triangles. But the difficult part then is that you would have to create a triangle list. I don't want to do that. But I am also not a fan of it being limited to the building having a height. Because that means that every building has to be perfectly cubic. More or less. Like, unless you count something above as part of the roof. And then that way you can make the roof, like, have wall tiles in it. Oh my god. I think for now we're going to skip this as much as we can. I do want to change this eventually. But for now, let's not. Where's my phone? I have a phone call coming in like an hour, I think. We're good. But I think I want to do the vertex solution, but only for 2D at the moment. I'm just thinking how it would be done. Hello, Killseed, how's it going? Because the room basically, what does it need to contain? It needs to contain does it really need the base Z? I don't think so, because the vertices would just contain the Z. But it does need a height. Actually, all we would need is a list of vertices. Because then what you do is... well, you need a list of vertices, but you also need a... like a count system. Where you have starting position, count. And then we iterate through them until we find the right one. And once we find the right one, we can then just use that ID, or the index that we're currently checking, to then access another buffer that just contains the world data. It would need to be a buffer that contains the room, like transparency, the current transparency and height. That is a way we can handle it too, to speed it up. Instead of checking every single room to see if we need to, instead of checking every single room to see if we are in that room, what we'll do is we just check an ID, and then we check if it's transparent. And if it isn't transparent, we just skip it. Because if it's not transparent, then we don't need to render the room as like anything special. Then it's just rendering the tile. And then that would be really fast. So how do we handle rooms right now? We have compute building data. Building transparency, room transparency, building transparency, roof transparency. This is unused? Find a wall building number is used. Are you having things like staircase gaps in floors? Yeah. I'm not sure if I understand what you mean, but staircases are not functioning right now. That's why I need to change it to be a... Because right now we're rendering tiles, And we actually need to render voxels, meaning it needs to have a top and a front, because otherwise I can't render staircases. Staircase gaps in floors. I'm not sure if I understand what you mean. Do you mean like this, that it looks like this? Or that the room is this kind of shape, or... Oh, yeah, you just mean that there's, like, a gap here for the staircase, right? Yeah, we'd have to have that. If there are any staircases. I don't think that there's really any issue with that right now. Not as much as there are with staircases. So I did this with vertices and mesh gen a while back. Maybe the constrained Delaunay triangulation algo might be helpful. This one is called the Müller-Trumbor. I don't think I would generate it as gaps. The way I would handle this is that the cutout is just a lack of tiles, right? So the way it works is that if you have a character standing down here on this floor, it then sets this building that this character exists in here, which will then remove the front of the building. And because we're standing in the bottom room here, it will fade away everything that's above. It'll hide the top, the above floor here. And it'll fade away if there's like a room that has a wall here. It'll fade this wall away. Then we see the character. So then if I were to go up the stairs here, it would, once we leave this room, I actually haven't really done much with stairs at all. But once we go up the stairs, once we arrive here, the character will be set to exist within this floor. And each floor is like a cube, right? And once we step foot in there, then this room would become opaque, potentially. Unless there's someone in there, then it becomes complicated. And then this floor would become visible, and then you would have like the bottom tiles here would become semi-transparent tapering, just so you can tell where that wall is. And then you would have the back wall here would be visible unless someone is standing behind the building, and then again it becomes complicated. But so it's something like that. Constrained Delaunay triangulation. So this is to create triangles. Yeah, meshing algorithm. Yeah. I wonder if just the regular Delaunay triangulation might work. If I end up using 3D solution. Which I should, but I don't want to do that now, really. But I feel like the main issue is... Go there though, let me know. I have some libraries that do it really well. Alright. You draw the borders of your mesh, then draw the borders of your gaps, and it just fills it all in. Right. Yeah, it's like you add like exclusion zones, I guess. Yeah, the core the core issue really is the initial meshing. Because it's like creating the 2D mesh at the bottom is easy. It's the second that you need to have a set of vertices at the top where things become annoying. But I don't know, maybe there's just an easy algorithm. Like you just grab a bunch of vertices and then you run it through an algorithm and it just like connects them together to form a polyhedron. Or something. Convex hull algorithms. It shrink wraps a set of points into the tightest possible polyhedron. MI convex hull is a library. A convex hull only works correctly if your intended shape is convex. No dents or indentations. Oh. If your vertices define a concave shape, like an L or a cave, the hull will fill in the gaps and give you a shape larger than intended. For a convex hull specifically, you can also skip the rate, blah 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 blah. How do you support concave shapes? Yeah, I guess. Maybe. Because if you have a shape like this, right? It doesn't necessarily have an order. It could potentially have an order, and I think it would work then. But it might not. And if you just shrink wrap it against all of these, without them having a specific order, then this could just as well become like this instead. And then you know, because this is, it finds these faster. So without an order, this wouldn't work. And because it's 3D, there is no good order. Because it would have to go like up and up to a certain polygon or a certain vertex here. But this might also be like this, and then you have like this, and then like that. And yeah, I can see it. I'll be right back. Lofting. There's something called lofting. I'm just thinking. So it's basically like... It's so hard to draw this, because it's in 3D, but... Basically, if we have this here, that means we have a shape that looks like this down here. And then on the next Z level, we have some vertices here. And here. And then on the next Z level after that, we have again vertices. Now we have vertices I guess here, 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 here. Everywhere. You then go through it in each Z level. And just connect it up. Or rather, here, for example, we'd have to reverse it. Because here, the bottom level doesn't have a vertex, right? So then this would need to create a vertex on the bottom level. There and there. I think. Because this is a concave shape, but it could be a convex shape. So every vertex needs to create vertices down to the bottom or down up to the top. More or less, unless there are vertices or like up to the next vertex. And then you connect those together. But how do you connect those together? That's the tricky part. Well, once you have Yeah, that is the tricky part. Because then you need to create a vertex order, right? It needs to be a 1D order. And then you need to set this to connect to the top one. And then the top one, and after the top one, it needs to be whatever it needs to connect to diagonally. So it would be this. And you need an algorithm to figure all that bullshit out. But maybe that's not that bad. That should exist. But either way, we shouldn't do that right now. What we should do is do something along those lines, but I just want to do a boundary check whenever we find a tile to see if it belongs to a room. I'm just thinking. Where am I? Where am I storing area content? Shadow area data. Compute dynamic shadow areas. Okay. I almost feel like this could be like one buffer just called like area data. But maybe that would be more complicated than not. Yeah. DirectX. What's a... Shader resource view. Oh my god, bro. You're always stepping on fucking landmines, but... In DirectX 11, you can have 128 UAVs and unlimited SRVs. In DirectX, you can have 64 UAVs. In Vulkan, it is device dependent. On Metal, 31 total. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Yeah, we're about 21. We're still well within acceptable limits, but we can only have about like 10 more if we want to be able to support Mac. I don't really care about that, to be perfectly honest. Like, if we can, sure. If we can't, I don't think I would put significant effort into supporting Mac architecture. But sure. But apparently, so it's a little annoying. So we have read-write structured buffers and we have structured buffers, and apparently the way I was doing it down here was that I was implementing a way to write to the buffers myself using these kernels, right? Because I thought that the immutable buffer type, or the immutable buffer mode, meant that you could only upload like on creation of the buffer, more like something like that, which was kind of weird, but it that's what it sounded like. But the immutable is actually the SRV, meaning it's just an immutable buffer is just a buffer that the CPU doesn't write to directly. Keyword directly. But the .set data function in Unity actually doesn't write to it directly using the CPU. It actually just allocates it via the GPU. So it's actually fine. So all of these could have still been just structured buffers, and some might still be valid as structured buffers, but like building data or whatever, that might be okay to still be a structured buffer. But like the tile data should not be a structured buffer, or it should be a read-write structured buffer, because it's about like being able to write to certain data sections to like update something easily versus having to rewrite the entire data length. More or less. But basically, when it's a read-write structured buffer, you can have less of them because they are much more involved. While structured buffers, seemingly, you can have infinite as long as it doesn't use up all of your memory. We're just gonna have to start somewhere, pretty much. This is one of those scenarios. I hate programming scenarios like this. It just... the scope of what I am trying to do right now is just a little too big, so I can't really like think of all of it at the same time. So I just keep like dropping parts of it in my mind. And then I'm just like, shit, where do I need to go right now? But basically, we need to write the rooms as vertices. Instead of writing the tile with a room ID, we need to write room vertices. And that's then gonna be a structured buffer of uint3 compute room vertices then we have another one and call that building vertices. And then we have another one called compute building vertices stride, and it's a uint2. Then we have another one called compute room vertices stride. Compute room vertices equals size of int times 3. Count 1,000. That's nothing. It's 12 kilobytes. We actually need another one, which is roof. And then the ones that say stride are actually 2, 2, 2. What's the last thing there? Light area map size temp. Maximum allowed length. Wait, how does this work? Memory settings, maximum allowed length. So these... Let's just set them to 1,000 and just say that they can't be... It can't be increased. I did try Warcraft 1, by the way. It was very bad. They hadn't invented standard mouse controls yet. Yeah, Warcraft 1 is dog shit. Warcraft 2 came out, and one of the features that was a selling point was attack move. Because plenty of other games didn't have that. Command & Conquer didn't have attack move. Command & Conquer I don't know if they even have attack move in Red Alert 2. Played 2 for a while, it was interesting but boring. Honestly, it's kind of like the same as StarCraft. More or less. I guess it just depends on the missions. Building data buffer. Compute building data. That contains Z values and height. Yes, I like to see the origins of things, but it was just too basic. I mean, the controls are much worse, but I do think it has everything that StarCraft has in terms of like actual depth. You know, you have casters with abilities, you have units with abilities, but it's a lot more ass to control and manage it overall. But otherwise, like, StarCraft is mostly just it's an improvement in terms of resolution, both in terms of like rendering resolution, but also in like play area resolution. Like, you can have small units and stuff and large units in a way that is different. Enemies kind of do nothing as well. Well, I suppose. I'm just thinking of it in like just pure gameplay mechanics. I don't know about the AI. Maybe the AI is garbage. Holy moly. I'm not ready for managing this again. Um, Here. Where is this? It's just right after. I think it's something like that. Actually, I think you can't... I think it has to be vector 3s, which is a little shitty, but... I think you cannot set... Here we have set data. Let's say new vector to int array, like that. Oh. What? On the GPU, a 3-component integer vector is padded to 16 bytes. Or ints. What do you mean? Oh yeah. Wait, what? Oh, right. Yeah. Okay, so in a C buffer, which I'm not using, and I don't know why, I don't know if I need them at all, but in a C buffer, a float 3 and an int 3 takes up 16 bytes, while in the structured buffer it's 12 bytes. So it's fine. Okay. Man, I don't even remember what I was doing. Okay, well in that case, maybe the int is fine. And now we need to assign all of these. I'll be right back. Also, I have a phone call incoming in like 10 minutes. rogue! Like that. There. And then in here, update buffers. Anytime a room is changed, we'll have to update the thing. So let's see, we need update room vertices buffer. Update building, update roof. And then in here, update building buffer. Update room vertices buffer. This is then a list of vector 3 ints. All room vertices list. Or world controller list I dot rooms dot count, and then for I don't know what to call it after that. IUJ world controller list I dot rooms U dot vertices dot count. All room vertices list dot add new vector 3 int. It actually only needs to be a vector 2 at the moment. But sure, let's do the vector 3. And that way we are adding all of the vertices in order. And all room indexing. Then here we're gonna say all room indexing dot add new vector to int, and then the count is gonna be int total rooms wait yeah, we need a total rooms. We also need current vertices, current vertex count, right? And then this is gonna be current vertex count and this. Rooms u dot vertices dot count. I don't know if this should be -1 or if it should just be count. Let's say we have a count of 1. Then we check the one we're at, and that's it. Yeah, dot count is correct. And then we can say current vertex count plus equals vertex count. So let's see. Compute room 30C's buffer manager dot set data, and we'll just set all room vertices list, and then compute room 30C's stride buffer manager set data all room indexing. Yeah. That should be okay. We shouldn't need to do any dispatching. I'm just updating the entire buffer. Update room vertices buffer. Then we copy that, and we change these names to building, building, and we go through the buildings. Building. Buildings. Okay, so the building doesn't need to contain vertices. Okay. Does a roof have vertices? Yes. Okay, I'll be right back. Alright, there we go. We're back. We're back. The building doesn't have a vertex, so that means we don't need this at all. We don't need to set anything for the building whatsoever. All we need is the room. The room needs to contain which building it belongs to, and that's it. But we do need a roof vertices buffer. All right. Something like that. I don't know if we have the correct stuff there, but basically what we need to do now is we need to write a function in here that simply does an AABB check against the thing. So public bool, no public. I don't know what we need to return. Let's just do void for now. No, it's not public. It's just void. Um, find tile room. I wonder, do we want to return like an find tile rooms? Then we take an int 3 tile position, and then we out an int array rooms. Oh my fucking god. How do you write it? And then we're gonna say got building data count. So it actually needs a room data count, roof data count, or roof count, maybe room count. Then we say int room count equals room count. And we're gonna say int start index equals 0. Then we need a for loop. I is less than 2, less than 3. Let's go with less than 2. I plus plus. I less than 2 should be world count, which might be 2 or 3. So then what we need to do here is as long as it's less than world index, we then say start index plus equals I dot room count then we're gonna do another for loop, and it's gonna say room count God damn. So then here we need int vert index equals compute room vertices stride This is I equals start index, and this should be start index plus room count. And then compute room. Where's room data? Compute building data. Room height. Man, this is so confusing, dude. I don't think it actually needs more than the room height. I mean, we could have the transparency in here. I suppose. It's just that the room height will need to be rewritten every time. Like, how is this handled right now? Compute building transparency. Yeah, it's basically all stored inside of this right? So if you access it with room 1, you get room 1, but you also get building 1 and roof 1. But yeah, I guess this does work. Like, this is okay. Oh, shit. Oh, this is so annoying. This is hard. Okay, so with that, what we can do here then is here. So this is the room. This should be the room index. So then we should be able to say if building get building transparency. No, get room transparency I equals 1. No, let's not return the rooms. We don't need to know that. We only need the transparency. That's it. But that's not entirely true either. Oh. The transparency, like drawing the rooms, is the worst. I hate doing this so much. There are so many like small issues all the time, because it's like All right. We're drawing this room. It has, you know, a certain a height, right? And you're like, yeah, okay, that's all good. We just check like which tile this tile belongs to room 2. We fetch room 2's z-axis, and that's like, yeah, okay. And then here, 2 rooms are overlapping, so we fetch room 1 and 2, and then you're like, okay, well, we'll just take like whichever transparency is the highest, or like the lowest, I think. Makes maybe more sense. No, I think highest. I don't know. It's either highest or lowest transparency, right? But then the question is, okay, but which Z do we use? Because like this room might have a lower Z than this room, potentially, except for like this wall. So then, what do we use for this? I think we use the highest Z. Simply. But then, like... Here it says transparency equals 1, but I think transparency 1 is fully opaque. So that should be opacity, I would say. This sucks. We should just be able to do this. If room transparency, then we continue. Otherwise... it should be something like... Hello, Metallic Chair. How's it going? It's going okay. It's heavy right now. Heavy stuff. We'll figure it out. But this is where we need to do... Basically, I'm updating some stuff in the renderer. And we basically have to use math to figure out whether the pixel we're trying to render, or the tile we're trying to render, exists within a certain room in the game. And then we need to fetch that room's transparency, and we need to fetch that room's height, and other various things. If compute room vertices room count okay, so int vert index is then compute room vertices stride I, and then we have to say if compute room vertices stride I vert index x dot z is lower than tile position dot x. No, it's greater than. Then we continue again. And that means that we're checking if the current tile that we're checking is simply below the vertices, then we don't need to check anything. And then we can also check or compute room vertices vert index dot x dot z plus compute building data I dot room height is less than tile position dot. No, this is tile position dot z. Then we continue. Oh boy. Okay, and after we have done that... Oh! There needs to be another for loop here. Which, I love that the snippet doesn't work. And the for loop this time should be... vert index.x. As long as u is less than vert index.x plus vert index.y. U. And then we're gonna say, this is so complicated. Room check. Room. I don't know where might this be? Room check. I need this, but easy. Like, if I could condense this. No, it's not this. Not exactly. I think. core. Now this is the setter. Point in poly. This is what I need. This is it. I should be able to kind of copy paste this, I think. But I feel like I can't... This can't be a function. Like, I feel like I just have to take this and just implement this. Raw here. And see, here we're now looping through vertices. It's this bullshit. Something like that. This is tile position. And then here we're gonna use room out index. So room out index. No. Room out index equals I. And then we break, I think. Same thing here. And then every time we do this, I want to say the only reason I'm setting it here as well, so that this doesn't happen. And then we run it again. And then I want to say if room out index equals 4, then we return. Something like that. Then the question is, where and how do we use this? I think here. Here we're fetching tile state from the level stencil. And that needs to go. Fuck. So much. Tile state. Int. Tile render. No, tile. What am I hiding in tile state? Tile state is... Because there's tilestate.r. I think we are using tilestate.b here. Yeah. Good morning, Kibs. And this is something I want to change, because this is ancient and it's just not good. So if we go to world controller, level stencil. I've removed it there. But what about here? Level stencil. I just want to see what it says. Like, what was I writing to the level stencil? It's not... It doesn't say. It might have been written somewhere else. Let's check the project. Now we're over here. World controller. But here it's also just setting the height, because I've copied it and stuff. Maybe here. No, I think this is just initializing it. Oh yeah, here, tile type and building ID. Right. So it's just the tiles building ID. So the level stencil, I think, is... We've already gotten rid of that. So all we need to do is tile... What did I just say? Tile type. Int tile type equals... compute tile data dot tile type. But then here we need to convert 3D to 1D index. Lord tile position X, Y, Z. And this is an int 3. That works. But it's not that easy either. And this should be a compute tile data. Tile data equals... We should fetch this here. I... Public... No. Compute tile data. Get tile data. And then that takes an int3 tile position. Then what we want to say here is we put that there. And we need an int start index equals 0. Then we need a for loop for int I equals 0. I is less than, let's go with 2, I plus plus. Actually, let's set it up. It's supposed to be just an integer up here saying int world count. As long as this is less than world count. Well, that's not true. It should be world index. And then we're going to say start index plus equals count world data count container buffer world index dot, no, this is I dot tile data count and then we're just gonna say return start index plus that. And that should fetch us the compute tile data. There. And then here we just say, if we want the tile type, we just say tile data dot tile type. But I'm not so convinced about that either. But we can go with that for now. It's just the tile data contains too much data, and the tile type, both the tile type and the tile state are like 8 values each. So that doesn't even need 8 bits. Like, how many values are 4 bits? Like 8? So for the time being, with 8 bits, I could have both tile type and tile state. Which means I could bake both of them into tile data, or into the detail data, because the detail data... actually, the tile data already contains that, doesn't it? Because if you look here, tile type is contained within tile data. So we could bake both tile type and tile state into tile data easily, I think. And this shouldn't be in here at all. Basically, every tile that we traverse, I'm just going to fetch the tile data now and the room stuff right in the beginning. And that's kind of how I was doing it before, but it felt a lot more complicated before. But that's because I was using a bunch of different textures to like contain all of the data. But I don't need to do that anymore at all. So, yeah, I'll be right back. How about some water? Maybe that would be a good idea. But what we could do, as you can see here, we have a tile data here. This is a compute tile data. I'm gonna sneeze. We can have a bunch of other things here. uint x2. I mean, detail, text, detail, UV, tile sheet, tile type, tile state can all be in here. uint tile detail sheet. Tile state, tile type. Tile UV. Now, am I using this at all? I might be. Here in no. Not even here. Raycast loop. I don't know if raycast data. Pixel color, render state, slice selector. Yeah, okay. Where do we... So this is the raycast data. So we're already fetching everything here, I would say. I'm trying to be big thinkies, but my brain is just kind of not thinking. But basically, we should add everything that we need to for the tile to the raycast data struct. And I'm just thinking what that would be. Because I'm just... I'm just checking. I'm thinking. Because if the tile type is a horizontal wall or whatever that's supposed to be able to be transparent, then we check for a room and building. But I'm thinking, like, do I need to actually add all of the rooms? I don't think so. I think all we need to do is, in here, as we check the tile, we check which rooms it belongs to, and then we just set it to... We set some values. We'll set... We'll set, like, we'll set transparency. Or should we set both room and building transparency? No, we should just set... For building, we should just set building ID. I think. Or maybe not. Building transparency. What am I thinking? It's almost stopping time, so it's no wonder that my brain is cooked. But basically what we need to do here is we just need to fetch all of the values properly here and add them to the raycast data instead of fetching them from those textures. And also converting this to take the world index into account. I'm trying. I would just like to write down some notes so that I can remember any of this. So, ray cast loop should fetch all of the data for each tile iteration. Set room transparency to highest or lowest value. Same with Z. With room height slash building height. Only check room if tile type is correct type. Also render state. What are the render states? Have I not written that down anywhere? Because I have the tile types, but I don't remember. As we are building it. Set transparent. Current state 2. Pointer 6. This is the first time in a while I wish I had... I wish I had some comment on this. What is current state? Ah, the slice through. That's what's stored in there. Okay. There are 3 states. I think the states are not transparent, room transparent, building transparent. That's render state. One, that's transparent there. 3, or 2. Where are we setting it to 3? Here. Is there some... This is in rooms. Room. If it's a horizontal wall, and checklist for any match, if the tile behind is empty, then render state 2 is the back wall, the building is transparent. Else, if there is a building behind, if there's a building behind, current state 3. Honestly, I don't know what the fuck 3 is. What is 3? Oh, I think 3 is a vertical wall. It's vertical wall transparency because it needs to behave in a certain way. The vertical walls and the horizontal walls have different requirements for how the transparency needs to work. Where... Yeah, that's it. Zero equals opaque. 1 equals... I actually don't know. 2 equals... I don't know. 3 equals... vertical wall. Oy! I actually think the I actually think Terry Davis's compiler was probably not that hard to make, but I'm not sure. But I have a sneaking suspicion it's not actually that hard. But I don't think it's easy either. Because I think he said something like it's like 2,000 lines or something, and I'm like, that's not really that much. Like, that's less than most game code is, but there's a lot of like memory allocation, a lot of complicating stuff in there, so those 2,000 lines are most certainly a lot harder than doing something that makes a lot more sense, like programming in Unity, but I don't think it's that big of a deal, actually. I think people do that just in school. Just building their own compilers. But yeah, like, you can make it about as hard or as easy as you want when it comes to this, but we were looking into like the ability to have like dynamic light and shadow casting from like torches and the sun and stuff like that. And also the ability to like walk in and out of buildings more seamlessly. And those things are a lot, like, they do make the game take longer to program, for sure. So it really just boils down to making sure that we make use of it. I think like walking in and out of buildings might not be like something that we do that much. I think we will, but it's not necessarily like a massive thing. But I do think like light casting and stuff will be cool. I'm also going to program in the ability for decals to like appear on the world. Like, for example, if someone is standing like here, let's say your character is standing here, right? And the enemy is standing here near the wall. I'm planning on making it so that if you attack this guy, it's gonna play out like this, right? Like you have this guy here, and then you have the enemy here. And then depending on the attack, that will have a certain effect, right? And let's say you are slashing at him with a sword. Then the effect in combat here, in the combat segment, might be that there's like blood splattered over here, like from him on the ground, right? And then that disappears. But what I want to do is I want to make this appear in the world after. So it's gonna come over here. And then, based on like the direction of the attack, the blood splatter is going to appear in that direction, and then it'll be able to like be on walls and stuff like that. And I already pretty much implemented this, almost. It's not that hard to do. That was one of the last things I was doing before I had to start reworking all this bullshit. But yeah. We'll stop here, though. We'll save that, and we'll continue later. Anything that has to do with the renderer, and we are in the renderer now, is unfortunately very hard to do in your brain, because it's very clunky code, so it's really hard to wrap your head around like what you need to do for it to work properly. But we are moving it along. And it's just that I also have so much code already here that I don't want to break, but rather everything that it's using here, I want to just change how it acquires that information earlier up here, right? So as long as I just change that here, most of the rest of the stuff here should work. But I might have to change some of these, like where we're fetching information from the buildings and stuff, a little bit, which is also it's gonna be a bit annoying, but I think most of it is fine, and we'll just manage. But everything that used the old system, where I had a texture that contained like information for every tile, like every pixel of the texture, a 3-dimensional texture, by the way, which means it's just like a clump of colors. Every pixel contained 4 channels of color, like they do: red, green, blue, transparency, or alpha. And each value goes from 0 to 255. And I just then stored data within that I then like unpacked into like an X position, a Y position, or whatever else was in there. But I've switched away from that system because that worked when we only had like one scene. But now that everything is being redone so that you can have like any amount of scenes, meaning you have like the world, and you have like the combat sequence is like its own scene, etc., etc. The old texture thing solution doesn't really work that well anymore. So I'm moving it over from textures into buffers, and that's basically what needs to be changed from like one system to another. And it's not really that big of a deal, but it is like slightly different here. Because it is better what I'm changing it to now, because here, for example, in order for me to get any information out of the texture, we have to load the color from the texture, and the color is a float value, which means it has decimals and shit that goes from 0 to 1. And then I have to multiply that up by 255. And then that it's like if you do this, like 0.7 times 255, then we get 178. We get rid of the decimal there. And I find it to be a little risky because it's, you know, it's very easy that there's some floating, like some rounding issue here that causes it to become like 177 when it should actually be 178. So we're just going to write raw, like real data instead of doing this, which will be a lot safer. And a lot less complicated, because here, as you can see, it's like I have to load this, we have to load the blue data value from here, multiply it by 255, and then we get a value for something, and it's kind of ass. I think you're right, it looks like writing a compiler. People use tools to translate it to assembly code instead of actually learning assembly. Yeah. I mean, I don't even know how hard assembly is. I think it's probably not easy, but I haven't ever looked at it because I don't really care, I'll be honest. I don't really care that much about like history, like video game history or how things work that much under the hood, unless like I care about it if I need it, more or less. And maybe like a little bit further than that, but not much. But yeah, that'll be that. Until next time, thanks, Ryan. Have a good day. Bye-bye.